Alright, so let's look at number 1 on the review. Evaluate the expression without using a calculator. So how do we simplify this? What do we do? Awesome. The cubed root of 8 to the 7th power. So our factors of 8 are 2, 2, and 2. We're circling groups of 3. So we get 2 to the 7th power. And then what's 2 to the 7th power? 128? Yeah. 128. Let's look at number 2. How do we simplify? Square root of 9 to the 5th power. So just remember, the bottom is the index. So same thing on the last one. The bottom goes out front. That's your index. So what's the square root of 9? 3, because 9 breaks down into 3 and 3. Circle groups of 2. So we have 3 to the 5th power. What is 3 to the 5th power? 243. So that's your answer. All right, number 3. What should we do first? Awesome. We want to get rid of that negative in the exponent. So since negative 27 is on top, to get rid of the negative in the exponent, we move that to the bottom. So negative 27 to the 2/3 power. So we move it to the bottom of the fraction. Now we just simplify our denominator here. So how can we simplify negative 27 to the 2/3 power? So the cubed root of negative 27 squared. Perfect. So the cubed root of negative 27 is negative 3, and then that's negative 3 squared, which is 9. So our final answer is 1/9. Awesome. Good job. Any questions on the first section, 1 through 3? All right, let's look at 4. What do we do first to solve for x? Subtract 17 on both sides. So x to the 5th power is equal to 18. What's next? Take the 5th root of each side. So this cancels. We have x is equal to the 5th root of 18. Let's see if we can simplify the 5th root of 18. What are our factors of 18? 9 and 2. And then 9 breaks down into 3 and 3. So 3, 3, and 2. Do we have any groups of 5 that we can circle? Nope. So the 5th root of 18 as simplified as we can go. So that's our answer. All right, number 5. What do we do first? Divide both sides by 7. So x cubed is equal to, what's 189 divided by 7? 27. What's next? Take the cubed root, cancel that out. So x is equal to the cubed root of 27. Let's see if we can simplify. What are our factors of 27? 9 and 3. Factors of 9? 3 and 3. Circling groups of how many? 3. So x is equal to 3. You can just write it. Things like that, we've done the cubed root of 27 so many times that it kind of like the cubed root of 27, the cubed root of 8, you kind of know those by now. But if it was like the cubed root of 700 and something, I would expect to see your work. All right, what do we do first here? Awesome, we need to take the fourth root first because we have these parentheses here. So we can't move the 8 over yet until we take the fourth root and get that exponent to cancel. So we're going to take the fourth root of both sides. So this cancels. X plus 8 is equal to what? But it's the fourth root, and 4 is an even number. So plus or minus 2. So remember, when you take the square root or the fourth root or the sixth root in an equation, you need the plus or minus. So I'll write that on the side here for you guys. If you take the square root, the fourth root, the sixth root, any even number, you need plus or minus in your answer. So we didn't do it in the last two because we had the third root and the fifth root, which were odd numbers, but we have to do it here because we have the fourth root. So we get plus or minus 2. So now we just have to treat this as two different equations. We have x plus 8 is equal to the positive 2, and x plus 8 is equal to negative 2. So then how do we solve for x? Subtract 8. So what's 2 minus 8? Negative 6. And we do the same thing for this one. Subtract 8. What's negative 2 minus 8? Negative 10. So we have two answers here. X is equal to negative 6 and x is equal to negative 10. Any questions? So just remember, when you are taking an even root in an equation, you have to have that plus or minus. So this is for even roots. Any questions on the last three that we did? All right, let's go to number 7. How do we simplify? Perfect. Our exponents have the same base, and we're dividing, so we can just subtract. So we have 6 to the 1/5 minus 2/5, but everything is still cubed. So let's subtract first. What's 1/5 minus 2/5? Negative 1/5. What should we do next? We can do that. So we have 1 over 6 to the 1/5. We make it positive since we flipped it. And then that's cubed. What do we do next? Then we just cube it. So we can say 1 cubed is just 1, because 1 times 1 times 1 is 1. And then how do we do 6 and 1/5 cubed? What do we do when we have an exponent raised to an exponent? Multiply them. So what's 1/5 times 3? 3/5. So our answer is 1 over 6 to the 3/5 power. Any questions on this one? All right, number 8. How do we simplify? What should we do? Multiply the two insides. Perfect. So that fourth root stays the same. And then we have 32 times 8. I'm just going to leave it as 32 times 8 because we're going to end up breaking it down anyways to see if we can simplify. So I could multiply 32 times 8, and what do you get? 256. But then we would say, what are the factors of 256? And 32 and 8 would be factors. So I'm just going to leave it as 32 and 8. So what are factors of 32? 8 and 4. Factors of 8? 4 and 2. So factors of 8 are 4 and 2, 2 and 2, 2 and 2 and 2. So we have 2, 2, 2. A lot of 2's. So we're circling groups of how many? 4. So we have 4 2's and 4 2's. So what comes out? 2 times 2, which is 4. Do we have anything that's not in a pair that has to stay on the inside? Nope. So our answer is 4. Yes.
Why wouldn't it be plus or minus 4?
Good question. So we only put the plus or minus when it's in an equation. So if we were taking the square root of both sides of the equation, but not for expressions. So here we're just simplifying, so we wouldn't put the plus or minus. So you don't need the plus or minus when it's just an expression. So no equal sign. Any other questions on that one? All right, number 9. Here we have 2 terms in our denominator. What do we do to get rid of those? Yeah. Perfect. We multiply it by its conjugate, so this would be times 2 plus the 4th root of 9. And whatever we do on the bottom, we have to do on the top. So let's multiply the bottom first. We have to FOIL. So this would be 2 times 2, which is 4. 2 times the 4th root of 9 would be 2 times the 4th root of 9 minus 2 times the 4th root of 9 minus the 4th root. If I do the 4th root of 9 times the 4th root of 9, I'll do that on top. 4th root of 9 times the 4th root of 9. How do I combine these two together? How do I multiply them? Put them under the same radical, so this would be the 4th root of 81. Perfect. So the 4th, like the radicals don't just cancel here because it is the 4th root. In the past, we've done this with square roots. So we said, oh, they just cancel each other out. We're just left with the whole number underneath. But here, since it's the 4th roots, they don't just cancel. So let's simplify our denominator. So we have 4. What happens to the 2 4th root 9 minus 2 4th root 9? Cancel. And then let's see what the 4th root of 81 is. So what are our factors of 81? 9 and 9. And our factors of 9? 3 and 3. We're circling groups of how many? 4. So we have minus 3 in our 4 minus 3 in our denominator. So let's see. Let's move on to the numerator. Well, actually, this would be 1. Let's move on to the numerator now. So we have 1 times 2 plus the 4th root of 9. So if this was any number other than 1, we would have to distribute it to both things in our parentheses. But it's 1, so it just becomes 2 plus 4th root of 9. It stays the same. So we have 2 plus the 4th root of 9 over 1. Which, since 1 is in your denominator, it would just be 2 plus the 4th root of 9. let's move on to 10. What can we do here? Add them. So what are we adding? The 4 and the 3. So this is like 4 chickens plus 3 chickens. So that gives us 7 chickens. Any questions on that one? All right, 11. What can we do here? Can we combine these together? No, because this is like 2 apples and 1 chicken. So they're different things, can't combine them. But can we simplify anything? The square root of 48. So what are factors of 48? 3 and 6, you said? No. 8 and 6. So 8 breaks down into 2 times 2 times 2, and 6 is 2 times 3. We're circling groups of how many? Groups of 2. So what comes out? 2 times 2. We already had a 2 on the outside to start out with, and then what stays on the inside? 3. Anything that doesn't have a pair stays on the inside. So we have 2 times 2 times 2 on the outside, which is 8. So 8 square root 3 minus square root 3. Can we combine these now? Yeah, because this is like 8 chickens minus 1 chicken. So what's 8 minus 1? 7. So we have 7 chickens. We had an 8 square root 3 minus square root 3, so this is just 1 square root 3 here. Like,
oh, okay, thank you.
this would be a 1. Since it's only 1 square root 3, we don't have any coefficients in front of it, so it's 8 minus 1. Good question. All right, let's look at number 12. All right, what can we do here? Distribute the 1/2. So what operation are we doing when we distribute the 1/2? Multiplication. So we multiply it to our exponent. So we have 5 and 2/3 times 1/2 times 2 raised to the 3/2 power times 1/2. So remember, when multiplying exponents, you multiply the tops together and you multiply the bottoms together. So this is 5 raised to the 2 over 6 power. Can we simplify 2 over 6? One-third. So 5 to the 1/3 power. And then we do the same thing for 2. Multiply the tops together, multiply the bottoms together. So 2 raised to the 3/4 power. Can we simplify 3/4? Nope, so 2 to the 3/4 power. Can we simplify any more? Do we have the same bases? No, so we can't combine them that way. Do we have the same exponents? Nope, so we can't combine them that way either. So this would be our final answer. So if we had both bases as 2, so if this was 2 and 1/3 times 2 and 3/4, what would we do here if we're multiplying? How do we combine these? So we add the exponents together. So 1/3 plus 3/4. So when you're multiplying and you have the same base, you add the exponents. We did an example in number 7 where we were dividing and we had the same base, so we subtracted. So here we're adding. So in order to add these, we would need to find a common denominator, which would be 12. So I have to multiply the top and the bottom here by 4. And then the top and the bottom here by 3. And then we just add, so this would be 2 raised to the 13th over 12 power. So this would be if they had the same base. But if they don't have the same base, don't have the same exponent, I can't do anything with them. Any questions? We still have 3 more left on this page. All right, 13, what do we do? Break it down. What are 2 factors of 125? 5 and 25, and 25 we have 5 and 5. We're circling groups of how many? So all of our 5s are going to come out, and then we do the same thing with the z's. We have 9 z's. 3, 4, 5, 6, 7, 8, 9. Circle groups of 3. So how many z's come out? 3. So we have 5z cubed. Nothing stays on the inside because we don't have anything without a pair. All right, 14. What should we do here? We don't have anything with the same base, and we don't have anything with the same exponent, but can we simplify anything? So let's take it one term at a time. We have 2 to the 1/4 power. Can we simplify that? Nope, that's as simplified as we can go. What about z to the 5/4 power? Which number would be our index? 4. So we have the 4th root of z to the 5th power. So we have 5 z's inside. So we have 1, 2, 3, 4, 5. We're circling groups of 4. So how many z's come out? 1. And how many z's are left? 1. Which I can change the 4th root of z to be z to the 1/4. Right? So remember, you can always take your index and just put it back as an exponent, but put it in the denominator. So I have z to the 1/4 times z times 2 to the 1/4 over 6z. Do I have anything that simplifies? Anything that cancels out? The z on the top and the z on the bottom cancel, so that I'm left with 2 and 1/4, 2 to the 1/4 power times z to the 1/4 power over 6. I have 2 to the 1/4 power times z to the 1/4 power. Can I simplify those since they have the same exponent? No. What if it was the 4th root of 2 times the 4th root of 2 of z? 4th root of 2 times the 4th root of z. I can put them in the same radical, so the 4th root of 2 times z. So I could just say that this is 2 times z to the 1/4 over 6. So that would be our simplest form. So because these have the same exponent, I can combine them. I'm going to skip 15 for now. I'll make sure I include it in the video if you want to see it, but we're running out of time, so I'm going to move on to the next page. Any questions on these two? All right, so we skipped 15, so I'm going to go back to it. Oops. So just like what we did in the ones before, we have to simplify as much as we can under the square root to see if we can combine. So we have the square root of 10z to the 5th power. Our factors of 10 are 2 and 5. Factors of z are z to the 5th power would be 5z's. We're circling groups of 2. So we take out z squared. We're left with the square root of 10z. We do the same thing for the other one. Our factors of 40 are 4 and 10. Factors of 4 are 2, 2, 2, 5, and z, circle groups of 2. So we take out a 2, and we have z squared, square root of 10z. So here we see we have our chickens and our chickens. So 1 chicken minus 2 chickens would give us -1 chicken. So we could put -1. You don't have to write the -1 there. So this would be negative z squared square root 10z. All right, let's look at 17. So here we have our transformations. So what does a negative being multiplied by the x on the inside tell us we do? A
reflection on the x-axis.
So remember, inside is y, outside is x. So you want to keep your x's outside your house. So this is inside, so it's a y. So reflection on the y-axis. And then what about the -6 on the outside? What does that tell us? Down 6. So we take our parent function. Do we have a square root or a cubed root graph here? Cubed root. So our cubed root parent function looks like this. And then we need to apply our transformation. So we have a reflection on the y-axis. So this is our y-axis. We flip it according to that. So it now looks like this. And then we just take it and shift it down 6. So if we start at 0, we're going 1, 2, 3, 4, 5, 6. So it now goes through there. Yes. So this blue graph is our graph of g of x. No, just go ahead. So remember, the squiggly snake-looking one is our cubed root graph. Our square root is just in the positive x. So this is our square root parent function. And this is our cubed root. You could. All right, let's look at 18. Let the graph of g be a reflection in the y-axis followed by a translation 7 units to the right of the graph of f of x is equal to the cubed root of x. Write a rule for g. So this is our parent function that we start with. We have a reflection in the y-axis. So what does that tell us we have to do to x? Multiply it by a negative on the inside since it's the y-axis. And then we have a translation 7 units to the right. So what does that tell us we have to do to x? Subtract it by 7 on the inside or the outside? The inside. So we have x minus 7 on the inside. So now we just combine these two transformations together. So we have the cubed root of negative x minus 7. So this is g of x. So you just take both your rules and apply them together. Alright, let's look at 21. What do we do here? How do we solve for x? Awesome, we need to isolate the radical, so divide by 4 on both sides. So this is the cubed root of 2x plus 1 is equal to 20 divided by 4, which is 5. What do we do next? Raise both sides to the power of 3, so this cancels. So we have 2x plus 1 is equal to 5 to the power of 3, which is 125. Now we just solve for x. So subtract 1. 2x is equal to 124. Divide by 2. What'd you guys get for x? 62. And then we always want to plug it in and check our work. It'll work here. Any questions on this one? All right, 22. What do we do here? Square both sides. So we always start by isolating the radical. Here it's already isolated. It's already all by itself. So to get rid of it, we square both sides. So we have 4x minus 4 is equal to x squared. What should we do next? Awesome. Subtract 4x and add 4 on both sides. So we get 0 is equal to x squared minus 4x plus 4. Now we factor. What are two factors of 4 that add to negative 4? Negative 2 and negative 2. We have x minus 2 times x minus 2 is equal to 0. Break it up into two equations. X is equal to 2 and x is equal to 2. So since they're the same thing, we don't have to plug them both in because it'll give us the same number when we plug in. So x is equal to 2. Take it, plug it in to check our work. So we have the square root of 4 times 2 minus 4 is equal to 2. So the square root of 8 minus 4 is equal to 2. What's the square root of 4? 2. So 2 is equal to 2. So it works. You always want to check your work when you have an x on the inside and an x on the outside. So always, always, always check your work when you have an x on the inside and an x on the outside. Any questions on that one? All right, last one, 23. 6x to the 2/3 power is equal to 36. How can we get rid of that 2/3 power? Raise it to the reciprocal. So this becomes to the 3/2 power. and raise it to the 3/2 power. So this cancels. So we have 6x is equal to 36 to the 3/2 power. How do we simplify 36 to the 3/2 power? Square root 36 to the power of 3. So square root of 36 is 6. And what's 6 cubed? 216. Divide both sides by 6. X is equal to 36. Perfect.